Edexcel Core Pure, second order differential equations 2, the non-homogeneous case, using a trial function to find a particular integral. So now we are looking at the second order linear equation, which is non-homogeneous because it equals 3x plus 4. We've already seen that the complementary function is y equals a e to the 2x plus b e to the minus x, and that is the solution for the homogeneous case only. So now we need to consider the non-homogeneous case, the 3x plus 4. So I like to think of this as the complementary function is a solution that will make the differential equation add up to 0, and now we're looking for an extra top-up function which will make the equation add up to 3x plus 4. And the function that will do this is called the particular integral. So when we're looking for this particular integral, we write down a function which we are going to try, which should solve the non-homogeneous case. And this so-called trial function usually has the same form as the non-homogeneous case. So if the non-homogeneous side is 3x plus 4, I would try y equals little ax plus b. Notice we use lowercase letters because we've already used capital A's and B's. So using or trying y equals ax plus b, dy by dx is a, and the second derivative is fairly obviously 0, and we now substitute these into the non-homogeneous case. So we now sub them into the full non-homogeneous equation at the top. So we need a second derivative minus a first derivative minus twice the trial function for y, and that must add up to the non-homogeneous side, 3x plus 4. If we now pick out the coefficients of x, on the left hand side we've got minus 2a is the coefficient of x, and on the right hand side the coefficient is 3, so they must be the same as each other. So our constant a is minus 1.5. If we now look at the constant terms on the left and the right, so on the left we have minus a minus 2b, and on the right the constant term is 4, and these must equate to each other as well. And using a, we can find that b is minus 1.25. So we have the values of a and b, and therefore we can write down what's called our particular integral. So the solution that would solve the non-homogeneous case is y equals minus 1.5x minus 1.25, and that is the extra top-up solution which would solve the non-homogeneous case. So to summarise, in order to solve a second order non-homogeneous equation, you first look at the homogeneous case and find what's called the complementary function. You then need to find this extra top-up function, or the particular integral, which will equate to the right-hand side. So in this example we had a linear right-hand side, so we tried y equals ax plus b, and by substituting for y and its derivatives we were able to find the values of a and b to give us our particular integral. So we've got the complementary function, which is the solution to the homogeneous case. We've got this extra top-up particular integral, which is a solution to the non-homogeneous case, and together the complementary function plus the particular integral will find the general solution to the non-homogeneous differential equation. Notice we still have two constants, a and b. So summarising the process now, if we're solving the second order non-homogeneous equation, you look at the homogeneous equation and find the complementary function, and then you look at the non-homogeneous equation and you've got to find a particular integral which would create that right hand side or equate to f of x. Together, the complementary function plus the particular integral will give you the general solution to the differential equation, and it will contain two arbitrary constants. So in the next video we're going to be looking at particular integrals where there is a polynomial on the right hand side.